Hello, hello, hello. Welcome to Cloud Native London, April 2022. My name is Cheryl Hum, and I'm your host for this evening's meetup. Thank you for joining us, whether you're joining us on YouTube, on Twitch, or on Rambly. So tonight, we're going to start off with a little bit of music. This is our agenda for the evening. So we've got about 10 minutes before we kick off with the welcome. You can also join us on Rambly, which is this little game thing where we all watch together and can chat to each other about the meetup. So if you want to join us live there, you can go to oishell.com/r. But for now, chill out, sit back, grab a drink, and I'll see you at 7 o'clock UK time, which is 10 minutes. Thank you. Hey everyone, welcome to Cloud Native London. We're going to kick off very shortly. So make sure that you've got a drink and you're relaxed and enjoy the meetup. Once again, feel free to join us on Rambly as well, our little 8-bit world where we chat together and watch the meetup together. You can go to that at oicheryl.com/r. Okay, I think let's get going with tonight's meetup. So this is our agenda for this evening. This is the April 2022 meetup for Cloud Native London. Okay, sorry for just killing straight that. But welcome. Cloud Native London is a strong, open, diverse developer community dedicated to the cloud native platform and technologies in London and across the world. My name is Cheryl Hung. You can find me at oicheryl online, including my blog, oicheryl.com. Tonight, we've got 3 fantastic talks, and I'm quite excited about this because they're 3 really interesting projects. The first one is called Hermod, Messenger of Kubernetes Deployments. Our second talk will be on Kubernetes native policy management with Kyverno. Then we will take a short break, a 15-minute break, before coming back for Kubernetes security and governance made easy using Otomi. And we'll wrap up at 9 o'clock UK time. I want to shout out to tonight's sponsors. First up, we have Palo Alto Networks. Palo Alto Networks enables your team to prevent successful cyber attacks with an automated approach that delivers consistent security across cloud, network, and mobile. From Circle CI, we have Zan. Zan, would you like to introduce Circle CI?
I would. Hi, everyone. Hi, Cheryl. I'm Zan, developer advocate at Circle CI. We're the leading CI/CD provider catering to all your test, build, deployment needs, whatever tech you're using, whatever stack you're using, whatever team sizes and languages, etc. you might throw at us. We'll probably have the chops to handle it. But today I would like to point you to a meetup we're hosting at the end of this month on the 28th of April in London in person and at CodeNode, which you might be familiar with. It's a venue between Liverpool Street and Moorgate stations. So you can find it at the GoTo Meetups London group. So because we're hosting it in conjunction with the GoTo group, it's called Circle CI Connect X GoTo. We've got Matt Turner from Marshall Wace speaking so far, and yeah, join us for some really cool times. And yeah, I'll be sharing the links to the meetup with Cheryl and other organizers so that they'll be adding it to the newsletter after the event as well. So that's all for me today. Thank you.
Brilliant. Thank you so much, San. And I got to say, I'm quite excited about going back to in-person events. So I'll hope to see you there as well. Our third sponsor for tonight is Sysdig. Sysdig is driving the standard for cloud and container security. With Sysdig, you can prioritize software vulnerabilities, detect and respond to threats, and manage cloud configurations, permissions, and compliance. Your teams get a single view of risk from source to run with no blind spots, no noise, and no black boxes. So I'd like to say thank you to all 3 of our sponsors tonight for keeping us going. Now I want to hear a little bit about you. So we're going to do a bit of live polling, learn about you, the audience. please go to this link, ocheryl.com/p, using your phone, your laptop, your whatever tablet. You don't need to download anything. That's going to direct you to this service called Poll Everywhere. And we're going to ask a few questions and just find out a little bit about you. First question, is this your first time joining Cloud Native London? Oh, yeah, you should see two buttons, yes and no. So just tap on yes if this is your first time and no if it is not. So it looks like it was changing a little bit. Hard to say whether yes or no is going to win out in the end. Feels like yes, a couple more yeses coming in. I'll give a few more seconds to give people a chance to log on to that link, ocheryl.com/p. If you forget that link at any time, you can also use this slightly longer link up here. Looks like we've got 2/3 yeses and 1/3 no. It's always exciting to see new people joining for the first time. Of course, it's fantastic as well to have people coming back. So either way, brilliant, loving having you here, and I really appreciate it. Well, a last minute no coming in there. Okay, let's try going to the next question. Where are you now? You should see a map of the world and just tap roughly where you are. This is just to find out, where we are, because we're all virtual at the moment. So usually there's a few people that are coming from London. I think, yeah, a handful of people coming from the UK, someone West Coast US, maybe, someone in India. Nice, a few more people. Oh, someone coming from Ireland, maybe. So just when you see the map, just tap where you are right now. Cool, couple of people. This looks like the north of the UK. Someone else in Ireland? Sweet. Okay, I'll give you another few seconds to find out where you are, to post where you are. Okay, let's keep going. What is your job title? Just pick whatever is the closest to what you do. So your options are architect, application developer, backend developer, engineering manager, SRE or DevOps engineer, security engineer, or other. And if it's other, then please post and tell us what you do. Definitely seems like SRE and DevOps engineers are pulling forwards here. Some architects as well. No application developers joining tonight. Again, if you are other, then feel free to comment and tell people what you do. Okay, looks like things are settling down. Now we've got a couple of questions which have been submitted by our speakers. So let's find out a little bit more about those topics. Your first question is, how do you make sure your Kubernetes deployments were successful? And your options here are looking at CI, Slack alerts, email, or just doing kubectl get pods. And this question came from Suraj, I believe. Yes, Suraj. Yeah. So, looks like it's very even. Is this what you were expecting?
Yeah, kind of.
Yeah?
Similar, yeah.
I feel like there should have been an option for more than one. I'm not sure if people can actually vote more than once on this one.
Yeah. No, I don't think so. It's just one option.
Just one option? Should have made it more than one. No one's saying by email at the moment. Yeah, it looks like a lot of people just do kubectl get pods.
Nice.
Awesome. Okay. Well, Looks like, oh, there might be some people changing their answers, I think.
Yeah, I think most of us are SRE or DevOps engineers, so that option makes sense.
Yeah, it's very true. Very true. Okay, awesome. Let's keep going then and go to our next question. I think Jim submitted this one. Have you heard of Kyverno and are you currently using it? Is that right, Jim?
Yes, would love to know what the audience is doing.
So the options here were, I've heard of it and I'm using it. I've heard of it, but I'm not using it. And I've never heard of it.
So Sam and I will hopefully change that by the end of the meetup. So everyone should have heard of it and know how to use it.
Nice. Yeah, hopefully you'll persuade the 38% who said that I've heard of it, but I'm not using it, why they should use it as well.
Sounds good.
Fantastic. I think these numbers have stopped. So yeah, you got 44% of your audience to tell fresh for the first time, hearing it for the first time. Sweet. Okay, let's go to our last question. Have you experienced a surface attack on your Kubernetes cluster? And your options here are yes, no, or maybe we don't know yet. With a nice winky face. Thoughts on this one? What were you thinking for this question?
So just wanted to have like a fun question just to get the pulse of the audience. And I was expecting maybe we don't know yet.
A lot of people are saying we don't know yet, which makes sense, right? Yeah, seems like 2/3, 64% of people are saying we don't think we've experienced one, but we don't know. Okay, last chance to get in your answers. Last chance. Okay, we'll call it there. Thank you so much for joining in on this live polling. Hope that you've learned a little bit and sort of got a bit of interest in what's coming up for you in today's meetup. With that, I'm going to hand over to our first speaker. So, Suraj, stage is yours.
Yeah, I shared my screen. Can you see?
Yep, looks good.
All right. Hello, everyone. I'm Suraj Narwade, and today I'm going to talk about Hermod. So before that, I'll introduce myself. So I am Senior Platform Engineer at RVU. I'm also a CNCF Ambassador, and sometimes I do make some cloud native videos on my YouTube channel. So for those who don't know what RVU is, we are a group of UK-based price comparison brands such as Uswitch, Confused, Money.co.uk, and we also have presence in Spain and Mexico with Restreator and Lelynx in France. So let's get started. So the question or like the problem statement we had was, how do we know that if the deployment is successful or not, and where do we go if something's not right? And kind of similar question I put in the poll as well, and for that many people mentioned keep looking at the CI or kubectl get pod. Now that many of us are SRE and DevOps engineer here, so I am kind of expected that, but it's similar, right? Like we jump onto the cluster and then we kind of follow routes. Like we look at pods, we look at logs, we look at events, and then we look at all different places, like as mentioned in this flow chart. This flow chart is pretty good by Learn KTest, but it's not really good for the developers who want to focus on their application and don't really want to learn Kubernetes. Maybe they want to learn, but they don't know much about it. So what should we do about it? How can we help them to speed up their development than tackling with Kubernetes and looking at what's going wrong? So to solve this problem at RVU, our platform team, we came up with this project called Hermod. Now, Hermod is a messenger of gods in Norse mythology. In our organization, we love to give project names after the Norse mythology. So that's the Hermod. And we wanted to have something like messenger of Kubernetes deployment. So as I mentioned, how does this work? It's very simple, straightforward. It's a controller which watches few resources such as the deployment, replica set, and pod, and then informs you what happened with the deployment on your Slack channel. Pretty straightforward. It's just a controller with bunch of permissions. Now, this Hermod, right? Like once I deployed, how do you get the alerts? So once you deploy the controller, all you have to do is put this Slack channel annotation on your namespace. The fine granularity we have given is the namespace, and just add the Slack app to the channel which you have mentioned. And as soon as you do that, you start getting alerts, whether they are successful alert or failure alert. So successful alert looks something like this, which says when the deployment starts means your developer makes some changes in the code, push the code and deploy it via CI. As soon as you deploy, it says ruling out of deployment, the name of the deployment in this particular namespace, and on this cluster if you have multiple clusters. And that is shown by orange color. And once the deployment is successful, it marks it with a green color and says this namespace, this application, this namespace is successful. Now, this may not be very helpful. You may be looking at errors. So if your deployment failed, now as a SRE or DevOps, you'll jump onto the cluster and do kubectl get pod or look at various logs and events. But for developer to make them like easier, Hermod, what will it do is it will just get them this alert in their Slack channel with a useful message. Now, in this particular case, it says rollout for this deployment, this namespace failed after 600 seconds on this cluster, and the error. The error is very straightforward and which says service account not found. Now, this must be very straightforward error, but for application developer, this is quite useful. They don't need to jump onto the cluster. They can straight away make some changes in the code, redeploy it, and then the iteration becomes faster. Now, one thing to notice here is it says after 600 seconds. So from where this time is coming. So in our deployment, there is a field called progress deadline second. So our Hermod looks at that progress deadline second time, and it waits till that time. And after that, it makes a decision to send the alert message with whatever information it has. There is one more feature that we have in Hermod is along with the error, it also shows the commit message and the pull request. So in our organization, on each Kubernetes deployment, we add the commit SHA when some PR is merged. So we can also retrieve that and add it into this message. It becomes very easy to track which commit was responsible for this particular failure, and we can like track that and make things easier, and we can solve the issue faster. Now these commits and pull requests, all these things can be configured on the Hermod itself. Nice. And in this particular case, the error was the image was not correct. Now, some of you might say that, I do loads of deployments and maybe I'm not interested in successful messages. These are too noisy. So you can just add another annotation, which is mentioned here on the namespace. And for that, Hermod will not send any positive or the successful messages. It will only send the messages in case of failure. We have also added a few metrics in the Hermod. Now these metrics are pretty simple, which is how many deployments Hermod processed, how many deployments were successful, and how many deployments failed. Now, these are pretty basic counter metrics, but you can gather very interesting information with the help of this metric, such as how many deployments we did in a day or maybe in a week, how many deployments were successful, how many deployments were failed, or how many deployments from these namespace were gone on particular day. That's where these metrics also come handy. So when we started Hermod project, we asked our developers, recently we asked our developers what they think about Hermod. So these are some quotes from them, like the immediate notification on deployment failure, it's good to track, and you can quickly debug without having to look in the cluster. So it's really helping our developers to fasten their development. So because of that, we decided to share with the wider community that what we learned and what we built. So we open sourced our little project Hermod. So it's open in our GitHub organization. So you can check at github.com/uswitch/Hermod. Give it a go if you like it. Make a star, fork it, and if you have any contribution, we will welcome the contribution. We are happy to accept it. And similar to Hermod, recently we did some open source showcase on our website. You can check that out, which has all our other open source stuff that we do. And last but not the least, we are hiring. You can check our positions at rvu.co.uk/careers. And I think that's it. I'll stop sharing. And if you have any questions, now's the time.
Fantastic. Thank you, Suraj. Looks like a very neat little utility.
Yeah.
Quite like. We're going to come and see some questions. You can go to that same link as before, cheryl.com/p, or you can use this link, polev.com/cherylhung278, to ask any questions for Suraj. I think this one came in earlier, so not really following up. I don't quite understand what this one is. So if you submitted this question, please submit another one with a bit more, maybe a bit more context about what you're asking. Suraj, like, do you have any future plans for Hermod?
So as of now, it serves the purpose, but we are definitely looking at adding more and more features. Like, for example, currently it only looks at deployment, but maybe we'll try to add something where it will look at cron jobs as well, or something like that. But yeah, that's for the future. There's one question: will Hermod links with only Slack? So Slack is the tool which we use internally at RVU. So we decided to go with Slack, but if you want to use with something else, feel free to fork it and add some extension to it. It's pretty straightforward. Nothing is tightly coupled, so you can just add any other, let's say, Teams or Discord, anything that you want. So yeah.
Excellent. Yeah, thank you. Any more questions, please feel free to submit them to this polling service. So while we have Suraj on the line. So Suraj, what kind of scale does this work at? Like how many deployments have you tried running through Hermod?
So now almost 90% of our teams are using Hermod at the moment. And currently in our cluster, Hermod is running with a single replica. It's not on HA at the moment, but still it's going well. I don't remember, it didn't broke at any time, so it's going really well. So we got a cluster of almost 80-90 nodes, and it's going well. Like it never broke. So yeah, but we do have plan to make it a HA setup, as there was a question, to make it like highly available. So yeah.
So with 80 or 90 nodes, are you processing like hundreds of deployments through it, thousands, like weekly, just roughly?
Yeah, roughly. Yeah, definitely.
Cool. Excellent.
Yeah, and just to add to that, there are these kind of errors which are like service account not found or image stack not found. For people like us, DevOps or SRE, these errors might be very simple and straightforward, but for the application developers, these errors, like if they try to find it via doing kubectl commands, it takes immense lot of time for them. So this just helps them. There's one more question: which database is it using? Hermod doesn't use any kind of database. It's just a controller, so it watches all the deployment replica set and pod in real time and make the decision and send the alerts.
But you mentioned that it also publishes metrics, so I guess you consume those via Prometheus?
Yes. So Hermod controller also exposes those metrics which you can consume by Prometheus or something to make some meaningful dashboard to see how many deployments you did in a day or maybe in a week. These metrics are good to show to senior leadership, definitely.
For sure. Yeah, I mean, that's a quite key part of, I guess, the organization. Cool. I'll give one more minute just to see if we have any other questions come in. Or if any of our speakers want to ask Suraj directly, you can also ask that. Oh, one more here. So if a broken deployment persists for a longer time, does Hermod repeat the notification?
No, Hermod doesn't repeat the notification. Hermod will watch the deployment only if there was a rollout to the deployment, there was some change to the deployment. If it is repetitive, Hermod will not do that. Cool. Yeah, and if there are any other questions, you can reach out to me on Twitter as well. My Twitter handle is Suraj in Cloud. So yeah.
Fantastic. Okay. Yeah, okay. If there are any other questions, then yeah, please feel free to reach out to Suraj directly. Otherwise, I think we can end here. Suraj, thank you so much. Really appreciate you sharing this project with us. I think it's really neat and just does exactly what it says. So it's great.
Yeah.
Thank you so much.
Thank you for the opportunity.
All right, we're now going to head on to our second talk of the evening. So Jim and Sam, over to you.
Thank you, Cheryl, and thanks everyone for joining. So we're going to talk about Kyverno and explain how it can be used to secure and automate Kubernetes configurations, and also can be used, in your CI/CD pipelines, as well as, in emerging use cases for software supply chain security, right? So just in terms of an agenda, what Sam and I had prepared is we'll do a quick intro to Kyverno. We wanted to keep the session mostly demo heavy, so we'll spend most of the time on command line showing how Kyverno can be used applied into your clusters. We'll cover some of the key use cases that we're seeing. We'll briefly talk about the additional features and things like that which you would expect in a production-ready policy engine, which acts, as an admission controller in your cluster. And then we'll wrap up with a quick summary and save some time for question and answers, right? So just quick introductions of the speakers on this topic. So I'm Jim Bugwadia, co-founder, CEO at Nirmata. I'm also a Kyverno maintainer, and just a bit of history on Kyverno and Nirmata. So Kyverno came out of some of the platform and tools we built at Nirmata. We open sourced it in 2019 and then donated it to CNCF in 2020. And then the community has grown quite a bit since then. So very excited to see the growth and this, the project mature. And we just applied for incubating status as well in the CNCF. I also serve as a co-chair in the policy working group and also work with the multi-tenancy working group in the Kubernetes community. And I'll let Sam quickly introduce himself before we dive into other topics.
Hi everyone, I'm Sam. I am an ML platform engineer at Bloomberg. I'm also a maintainer on Kyverno, and I also maintain the Cloud Native Build Packs project, along with a few other projects like Sift, and I contribute to a few other projects like Sift, Gripe, Sixter, and CycloneDX. My main focus as a Kyverno maintainer is supply chain security, and we've been contributing a bunch of features to provide a really cohesive experience around supply chain security in Kubernetes clusters through Kyverno.
All right, thank you, Sam. Okay, so let's dive into it with a quick intro into Kyverno and talk a little bit about the background of the project, but more why it exists and what we're trying to achieve with it, right? So in a nutshell, Kyverno was designed as a policy engine for Kubernetes itself. Some of your folks who have used other policy engines may know that there's other alternatives like OPA or Open Policy Agent, Gatekeeper. But one of the things that we saw and what we were also, as we spoke to other folks deploying, managing Kubernetes at scale, is there seemed to be a compelling need for something designed for Kubernetes, which understood how Kubernetes patterns, idioms, primitives work, and could leverage those to offer policies to Kubernetes administrators. And the idea was, of course, as we were seeing, Kubernetes is extremely powerful with its declarative configuration capabilities, right? So you can, when you're specifying whether any manifest, whether it's for a pod or deployment, even for an entire workload, there's tons of settings that you can specify in your configurations and in a very declarative manner. However, along with this, because of that declarative nature, the configurations do tend to get very detailed. And there's also several different roles that might be involved, like your ops team, your security team, and of course, the developers who are trying to deploy and manage applications. They're all involved in some aspect or the other of this configuration. So what became apparent as we were looking at this complexity is there needs to be a way through policy definitions and using that same declarative approach that Kubernetes specifies. Why not make it easy to manage these configurations at scale? And that was the sort of genesis of the emergence of Kyverno. And the idea was, policy should not be just for security, but also for automation, right? So how do we simplify managing these Kubernetes configurations by automating as much as we can, by taking away some of those, again, the need for coordination and those manual handoffs, and do it in a manner which is extremely intuitive to folks who have already put in the effort and time to learn Kubernetes, right? So make it native to Kubernetes, no language, no external, kind of learning curve, and simple to manage and scale. Now, the one thing you'll see is that simplicity doesn't compromise with the complexity of policies that can be handled with Kyverno. Kyverno does have full capabilities of handling fairly complex rule processing. It has things like being able to do API lookups, manage external data sets through config maps, as well as can do things like loop over elements using for each constructs, etc. Right? So the idea is keep it simple, but still provide a lot of value and power, much like Kubernetes itself. So some of the common use cases we see, and just starting with basics, and we'll do some demos on most of these as much as we can, given the time constraints. But uh, Kubernetes, pod security, of course, is one of the fundamental, in your security toolbox. That is one of the fundamental steps in securing Kubernetes. So we'll start, that workload is something that we commonly see. Also, best practices beyond just pods. How do you secure configurations, whether it's your namespacing, using namespaces correctly, services, even things like setting up your ingresses, and we are seeing every it's not um, uh, too often, but at least every quarter we'll see one or two new CVEs, new vulnerabilities reported, which can be tightened up or which can be prevented through Kubernetes configurations. So there's an evolving set of policies, and I'll showcase where to find those that are available through Kyverno itself, right? And then the other use case, we see is for on the automation side, is also mutating resources, being able to generate new resources. And there's use cases like multi-tenancy when you want to do namespace-based multi-tenancy. How do you kind of automate as much of the configuration as possible for your developers, or in some cases, if you're using multiple instances of the same application as a SaaS provider, there's a fair amount of automation that you can do now with Kyverno. Also, CI/CD, workflows, integrations into CI/CD, being able to do static and analysis on your YAML manifest, and give that feedback to developers early to say if they are following best practices for their pod configurations, for their deployments, and other Kubernetes constructs, right? So you can, with Kyverno and with the CLI option for it, you can easily integrate this into your GitHub or GitLab or any other, Circle CI, any other CI/CD tool, which can be used then to provide that feedback early in the life cycle. And finally, the use case that Sam talked about, and we'll all do a demo on this as well, is on container image signing and software supply chain security, which, given the sharp increase in attacks in your CI/CD pipeline, things like we have seen, like the SolarWinds breach and other incidents, has become a top priority for folks, right? So these are some of the use cases, but it's an evolving and emerging set. And as the community grows, and one thing I'd to point out about the Kyverno community is, and also the maintainers on the Kyverno side, we are fortunate enough to have maintainers like Sam who are also end users, right? So we're always seeing this list of use cases grow, which is very exciting. So let's dive into what a Kyverno policy looks like next, right? And just to explain the structure, and we'll see a lot of these policies in action. But in Kyverno, a policy is really a composition. It's a set of rules. Each rule will match or exclude resources. And Kyverno operates as an admission controller, as well as can do background scans. So when it operates as an admission controller, it can match and exclude resources based on all kinds of information in the admission request. It can also, you can leverage API lookups to look at things like namespace labels and make a policy decision, whether some rule should be applied or not, right? And once that's done, once you have filtered the set of rules that need to be applied, you can either mutate resources in the mutating webhook, validate resources, you can generate net new resources, like again in the multi-tenancy use case I mentioned. You can verify images for signatures, for attestations, for image configuration data. So lots of interesting things that you can do within a policy rule itself. And then you would have a set of rules which apply in your cluster. Each rule is completely idempotent. It doesn't, there's no hierarchy of rules. You cannot override, one rule cannot override another. So each rule is applied independently and atomically, and the policy engine then makes a decision of whether to allow or deny based on the settings in your policy configuration itself. So if the policy is set to, to enforce, then what would happen is that a request would get blocked by the Kubernetes admission controller. So you will see the response back in kubectl or whatever tool you're using to deploy. If the policy is set to audit, Kyverno will allow that resource to be deployed, but through the policy reports, it will show violations, as well as through Kubernetes events, you will see violations in the resource itself. So the idea was to make it extremely easy, extremely user-friendly for developers to get these type of notifications and to understand where their resource may need some tweaking to comply with the policies. So quick, example of a rule and how a policy in, Kyverno. So this is a policy which is requiring a label. So a few things to point out is that, the policy here is declarative in the sense it matches the resource definition, right? And it's interesting because when you talk about something being declarative, you can be declarative at different levels of abstraction. In fact, if you look at the OPA Rego documentation, it states that Rego is a declarative language, but Rego is declarative at the JSON level, right? So if you're processing JSON, well, yes, Rego is declarative at that level. Here, the level of abstraction where Kyverno is declarative is at the Kubernetes resource definition level. So the policy matches what the resource definition would look like. In fact, it's a partial fragment, as you see over here, and we're just looking at the metadata in any pod, and we're then checking for a label, which again matches how labels would be defined in the resource. And in this case, we want the to make sure that a label called app.kubernetes.io/name exists, right? So extremely simple but powerful policy, which is just proper hygiene. You want to make sure that resources are labeled. So you can set this and enforce, this policy, or you can audit for, violations and report those back. Now, like I said, beyond these kind of simple examples, which are nice always for demos and things, in the real world, there's a lot of complexity required when you're writing and managing policies. And Kyverno has that ability through things like variable substitution, external data lookups, JMSPAT expressions, which allow you to do some very powerful processing on JSON data sets. Like I mentioned, even looping through constructs, looking deep into a resource and applying logic there. So lots of interesting examples, and we have a policy sample library with about 140 different policies, which give you a really good foundation to get started with. So with that, let's dive into demos, and we will kind of look at different policies, so you will kind of get a flavor for what these look like. But before we go to demos, I just want to kind of go to the Kyverno.io site. And I mentioned a few times this policy library, right? So I'll just kind of quickly show how you can get started or look at different policies, right? So if you go to Kyverno.io, click on policies, you will see like all the different policies. And let's just click on the first one as an example. Each of these policies, you will see again, like some of these can be, more complex than others. This one is actually doing a mutate, which is injecting a sidecar with some sort of particular certificates, and it's replacing that in a container, right? So if you have a custom CA, and this is a use case which came out of one of our customers at Nirmata. They had custom CAs where they needed to periodically rotate those and update those for their users, and they were able to easily solve this using Kyverno through a sidecar injection, right? But there's several examples, so certainly would suggest looking through these, looking for whether you're looking at the security or other sort of best practices that you want to roll out into your deployments, as well as help your developers and end users. So with that, let's head over to the documentation and see what we can do and actually use Kyverno. So what I'm going to do is I'm going to start with a simple demo, but with a very basic example of pod security, right? So as a lot of you may know, so pod security, PSPs used to be a built-in construct in Kubernetes, but they were marked for deprecation in release 1.22. And the plan is PSPs will be completely removed by 1.25. There is a new construct called pod security admission, which is available in, I believe it's currently in beta, and it will, it's planned for GA before PSPs are completely removed. Pod security admission, like the name suggests, is an admission controller as well, but it does pod security at the namespace level. So the Kubernetes community chose that as a good trade-off between secure by default best practices to say, to provide, pod security, some basic pod security at the namespace level. So what you can do is if you go, in fact, there's a pod security standard document, which is part of Kubernetes, the documentation, which defines 3 different levels: privilege, baseline, and restricted. And the idea would be that with pod security admission, you can set a default of baseline, or you can set a default of restricted if you want to be highly secure, and then that will apply to all namespaces. The challenge, though, is in most real-world use cases, it's not that simple, right? You're not going to be able to set one policy across all namespaces or across even all workloads within a namespace or all constructs within a namespace. So that's where the recommendation is, if PSA is not sufficient, which typically most deployments will require fine-grained controls, then to start leveraging a combination of PSA at a baseline level, but then use policy engines like Kyverno or OPA Gatekeeper for finer grained controls, right, which will be typically required. So this pod security standards provides a list of controls, a list of settings, everything you need to do to comply to that. And then you can again start with the secure baseline level, or with any of these levels that make sense, but then use something like Kyverno for that finer grained control, right? So what I'll show is I'm first going to install Kyverno on a simple cluster, and then we'll come back to this, and just to kind of show you the installation and how straightforward that is and how easily you can get started. So there's a Helm chart that's available in Artifact Hub, so you can kind of check that out. And if Helm is your preferred way of installing and managing Kyverno, any workload, you can use that. But what I'll do for this demo is I'm just going to go ahead and use the command line option to install Kyverno, right? So if I scroll down here, it tells me, how with kubectl I can install Kyverno, and I'm going to pick a release version here. Head over to my Minikube cluster. Let me make that a little bit bigger, and we'll just go ahead and install Kyverno on this cluster, right? So as you can see, it's pulling down a number of different resources. These are CRDs as well as some roles. Kyverno has a very fine-grained security model. And in fact, we worked with SIG Security to come up with a threat model for admission controllers. And Kyverno abides by that to provide, a fairly good security posture and with, controls where you can further refine that and tweak that, especially it being a critical part of your cluster infrastructure as an admission controller. So now that Kyverno is installed, let's make sure that everything's running. So I'm going to just do -n logs. I'm going to check for my deployment logs. I see here that Kyverno came up. It's saying it created some webhooks. So it started listening to API requests. And now it's waiting to get API requests from our server, right? But at this point, I don't have any cluster policies installed. So if I do get cpol, cpol is short for cluster policy. There's nothing, there's nothing installed on this cluster, right? Which right now it doesn't have any of those policies. So what, like I mentioned, pod security is fairly, basic and something that's very required in Kubernetes. But let's kind of understand a little bit more about that and why, right? So in Kubernetes, if you give somebody permission to run a pod and you do not have any way of enforcing pod security, anyone who can run a pod, and again, if your configuration is not blocked, you can, ask for privileged, mode within the pod itself. You can run that pod potentially as a root user, and like this command line shows, and I think it was. I saw Duffy Cooley demo this once. I believe it was at a KubeCon. Which is it's a pretty slick way of running a pod, but then elevating privileges and doing an NS enter. Which again, if I have no security controls, let me actually delete this pod. I think I had that running before. So if I have no other security controls at that point, I should be able to run that pod. And again, if it's allowed, I'm going to be able to get access to host as root, right? Which is again, by default, all you're given is a user permission to run a workload. But Kubernetes is not going to prevent this because again, it allows this for when it's required, but it's up to you as an administrator, as a Kubernetes, cluster admin to make sure that you have the right controls in place where some workload which is not privileged cannot do this, right? So if I see where I am and I'm running a Minikube cluster, but I'm already here, at basically, at my root, and if I kind of let's try to go under var log, see what I can see, there's a containers folder. If I look at var log containers, sure enough, I see the logs of every container. I can even probably go to, if I go to etc Kubernetes, depending on how this cluster was involved, I'll find like, how the control plane was, involved. If the control plane was brought up using kubeadm, there might be secrets here. So not a good thing, right? And this is again just stock Kubernetes without any security controls, without any policies on it. So obviously we want to do better. And what I'll show is how you can very easily, again, with a couple of commands, go from zero security on that cluster to a very secure posture where you're, enforcing the restricted pod security profile and not allowing, any pod which can elevate privileges or violate any of the best practices as defined in the pod security profiles. So now what I did was I just ran this command which I'm using kustomize. The nice thing about Kyverno policies is because it's declarative YAML, you can use any tool that you're using to manage Kubernetes. Kustomize works great with kubectl, right? And this customized profile that I pulled down is actually setting the policies in enforce mode. So now if we do kubectl, and get cpol again, what we should be able to see is we have a set of policies. And as you can see, they're flipping into enforce mode in a few seconds. all of these will go, so Kyverno is processing these policies, validating these, and setting them to enforce. So just to kind of, show that now, once I have these policies applied, what happens if I try to run the same command again, right? And the first time we did this, it went through. But if I run this again, Kyverno immediately rejects it and says, hey, the best practices as described in the pod security policies are to drop all capabilities. You can't, attach to the host namespace. You can't elevate privileges, and so on, right? So simple demo, but just to show how, in a few seconds, by installing Kyverno and running, this set of configured pod security policies, you can go to a fairly restricted mode, and make sure that your control plane as well as your other resources are protected, right? So container escapes are not allowed, and you're not able to kind of go from within the pod into host like we were able to do before. So that's the demo I was going to cover, and I'm going to hand off now to Sam, who's going to cover a few more demos, and then we'll come back to Q&A and other topics.
Yeah. Thanks, Jim. Just a second. I'll switch over to my demos. Are you able to see my VS Code screen? Yeah.
Yes,
okay.
we can.
Cool. So I'll be demonstrating a bunch of capabilities that Jim just talked about with some real-world use cases. First up, we'll be looking at how validate, mutate, and generate policies work, with the example use case being managing a multi-tenant cluster. Multi-tenancy has been a fairly common paradigm in Kubernetes, and you typically want appropriate policies and controls in place for each namespace so that there's no noisy neighbor effect. One namespace is not blowing up your entire cluster. So I have a fairly simple but powerful demo here, and let me just walk you through it. So I'm just using a small script to make sure that I correctly type my commands and don't mess up this live demo, but it's actually running all of these commands against a live cluster that has Kyverno installed just the way that Jim demoed. So first of all, what we want to do is add some additional permissions for the Kyverno controller. By default, Kyverno doesn't have cluster-wide permissions to create cluster-wide resources. So in this specific case, since we want the generate controller to create certain cluster bindings, we're creating some additional, we're providing it with some additional permissions. Next up, I want to show what kind of policies we are going to go through. So we have a bunch of these here that you can see on the top, and I'll be walking through each of them. So first up, the example use case we have here is we have a few tenants who want to self-provision their own namespace. And we, as the Kubernetes cluster administrator, want to make sure that when they do provision their own namespace, certain policies are enforced, and certain resources that we require each namespace to have are created automatically. So first up, what we want is whenever someone is self-provisioning a namespace, they must define what kind of a namespace it is and what kind of resources they're expecting to create in that namespace. So first up, we have a cluster policy that looks at namespace resources and ensures that the namespace is annotated with a label of small, medium, or large. These labels will decide what kind of limit ranges and resource quotas each of these namespaces have. So first up, let's try and create a namespace as the sample user called Nancy without any of these labels. So as you can see, our Kyverno with its validate mode on is preventing Nancy from creating any namespace without these labels set. So let's actually create a namespace that has a label. So I'm creating a namespace with label type medium. So I'm going to try and create that again as Nancy, and this time it should hopefully go through. So yeah, it was created. And along with the namespace creation, as I'm going to show in the next few, with the next few commands, we've also created some resources in the background in that namespace, and also given Nancy, the creator of that namespace, a few elevated permissions to manage and completely administer their namespace without having to worry about things. So first up, what we've done is made sure that Nancy has admin privileges in their namespace. And we also make sure that the namespace is actually annotated by the username of the person who created it, or the user who created it. So you can see we have two policies here. First up is a generate policy. The generate policy sets up appropriate cluster roles so that the creator of the user gets appropriate permissions to fetch the namespace and delete it, so they can clean up afterwards if they don't need the namespace anymore. And it also generates the role binding for them so that they have access to they have access to the namespace. And finally, we have a mutate policy that, as I described earlier, adds this label to the namespace and injects the username of the user who created it. So if you go back and check our namespace again, we'll see that Kyverno indeed added a created by label and added the username, which is Nancy, there automatically. We were also able to get this namespace, which was a result of these role bindings that we created during namespace creation, just to make sure that no one else can access this namespace and it's only Nancy who has access to that. I'm going to try and get that namespace using a user called Ned. As you can see, since Ned doesn't have the appropriate role bindings, they're not able to actually fetch the namespace or do anything with it. So you've taken a complex task like namespace provisioning and automatically setting up permissions and any appropriate controls in there, and made it entirely declarative. So like all of these policies can be modified to suit your specific use case. And you can make all sorts of customizations using simple declarative policies. Let me show you a few more examples of how powerful this is. So next up, as I said, we've also provisioned a role binding for Nancy. So Nancy has admin role binding on the namespace. But apart from role bindings and just these labels, we've also generated a few other resources like adding a default network policy, adding some default limit ranges and quotas based on the type of the namespace that Nancy created. So remember, Nancy created a medium type namespace, and I'll show you what these policies do. So first up, we have the add network policy generate rule. So what this actually does is it creates a default deny network policy in each new namespace that's provisioned and prevents any ingresses or egresses from happening. So that's like one network policy that will be generated each time a namespace resource is created. Separately, we've also got policies that add limit ranges and resource quotas to each of the namespaces, depending on the type of the namespace that was created. So you can see for namespaces that have the type set to small, we're setting limit ranges with some small values. But if you go higher up the ladder, like medium or something, these values increase. Similarly, for large, we have, again, a higher policy. We have something similar for resource quotas, like as depending on the label, we provide more resource quotas for you based on the namespace you've provisioned. So if I go back and get the network policy, you'll see that the default deny network policy is actually in place. Now, one really powerful thing about the generate controller that Kyverno has is that right now Nancy has admin permissions on her namespace, which means that she's able to do things like delete this network policy that we as the cluster administrator wanted each namespace to have. The generate controller is smart enough and it will listen to Kubernetes events and make sure that any resources that were generated as part of the Kyverno rule are actually maintained in that state regardless of what happens. So if Nancy goes ahead and deletes that network policy, we'll see that the generate controller has recreated it again. So you can see that previously the resource was created 4 minutes ago, but now, like, even after deletion, it's been recreated after a few seconds. So it's not just a one-time thing. The controller is actively watching for events and making sure that the rules and policies you've defined stay synchronized with the current state of the world. Similarly, like, let's say we're done with this whole demo and I'm done using this namespace and I want to clean it up. So as I showed previously, the only person who should be able to clean up this namespace is Nancy. So let's try and delete that namespace as some bad actor called Ned. You can see that we've actually prevented Ned from doing that. But on the other hand, if we run the same command as Nancy, it should allow us through. And we have successfully automated provisioning and cleanup of a namespace along with some default resources and policies that we want each namespace to have. So typically when people think about policies, they think about mutation or validation. But generation is, again, a really important and smart capability, especially when you're thinking about multi-tenancy use cases, where things like preventing any new namespace from accessing any external network is a policy that you've defined. But in order to express that policy, you need to be able to generate a few new Kubernetes resources. So that's why this generate controller that's a part of Kyverno is also fairly powerful, and it augments the whole Kyverno as a K8s native policy engine concept to the next level. And that's something very unique to Kyverno. So that's it for the multi-tenancy demo. I hope that gave you a brief idea of how you can use the generate, validate, and mutate rules to effectively provision a multi-tenant cluster. Next up, let's take a look at a few of the supply chain security use cases that we were talking about. So let me just go to the image verification demo and start it up. And I'll walk you through the different kind of policies we have here to just demo a few capabilities that Kyverno is capable of when it comes to enforcing supply chain security best practices in your cluster. So first up, like a really common use case is you want to be able to prevent root users, like container images with root users being run on your cluster. So maybe you don't want users to have escalated privileges even within the container. So typically you can do that also via pod mutation policy that changes the user, but like that may have some side effects. Like you might want certain containers to run as roots, whereas you might want certain containers to not run at all. So this is an interesting policy that, rather than looking at the Kubernetes resource, actually looks at the image used to create the pod and gets its OCI config and finds out if the user is set to an empty string, which is what it's set to when the user is set to root. So here what we're doing is anytime that a pod is created and like it's not being deleted, it's being created or modified, for each of the containers defined within the pod, we are finding the image of that container and doing an image registry lookup and storing it in a variable called image data. Once we have all of that data stored, we are looking at the OCI image config and finding out what the user for that specific image is set to. And if it's set to an empty string, then we are denying the pod from being created. So one really interesting thing is that even though this policy is defined at a pod level, Kyverno is smart enough to auto-generate similar policies for higher level resources like replica sets, deployments, jobs, etc. So you only really need to define the policy at a pod level, and it can automatically generate it for these other higher level resources that you'll typically be interacting with on a Kubernetes cluster. This behavior can obviously be disabled, but by default, it's enabled to ensure that there is consistency between the higher level objects and any child resources that they're creating. So in this case, let me just apply this block root user policy. And once that's applied, what I want to do is create an image that has the user set to root. So I'm using a simple image called busybox, which is a really small image that contains a bunch of tools, but the default user is set to root. I'm going to try and run that in the dry run mode. So another thing that Kyverno is capable of is, since all of the webhooks it installs are idempotent, all of those also have the dry run mode enabled, which means even before creating the resource, you can just do a dry run and check whether the API server will admit your resource or not. So here, I'm just trying to create a new deployment where I'm running a container whose image is set to busybox, and I'm dry running it against the server, not on the client side. I want to run it against the server so that the Kyverno webhooks actually have a chance to look at the resource and then allow or deny it. So doing that, I see that the resource was blocked, and it was blocked with a nice message saying that images with root users are not allowed. And you can easily define these message strings to provide good feedback to your end application developers and not some cryptic error messages. So now let's try with an image that doesn't have the user set to root. So I'm just going to use the Kyverno controller image, and I'm going to dry run it against the server again. You see this time the API server lets it go through. Just to show you that this is actually because of the policy I just applied, I'm going to delete that policy and retry creating a deployment with the busybox image, and this time it should be let through. So yeah, that's one example of a supply chain security use case where you want to prevent images with root user. Another one that's fairly common is that you want to prevent images that are stale or like that have been created a long while ago. Typically because images that have been created a while ago probably don't have the latest security patches and bug fixes. So in this case, what we're again doing is for all pods, we're going through all containers, fetching their image data. And then if they were created more than 6 months ago, we're going to go ahead and block them. So that's again a very powerful capability that you currently don't get with any other out-of-the-box solution like this. So I'm going to apply this thing again. And I'm going to try and create a deployment with an old version of Ubuntu. So this specific version was released in 2018 October. And then I'm going to dry run it. And since this is a very old image, the API server obviously denies admission to this specific deployment. Similarly, if I now try with a newer version of Ubuntu, which was released this month, and try to run it, we see that it's let through. So again, like this is it's a fairly powerful way of defining supply chain security constructs in your Kubernetes cluster using very little YAML. So all I had to do was just make sure that I'm going through each of the containers and just checking the creation date to a specific value. And you see Kyverno is smart enough to handle quantities like durations or memory or CPU or other typical quantities. So it's not just numeric, but it also understands quantities like hours and durations. Next up, another use case that I want to demo is being able to mutate a tag to an exact bin digest. So there are lots of tools that can do this for basic Kubernetes resources, but with Kyverno, you can also define it for any kind of resources, including custom resources. So in this specific example, I again have it for pod, but since all of this is just YAML based instead of spec.containers, you can replace this with practically anything. So let's say you have Tecton task or an Argo workflow, and you want to make sure that all the images at the top level workflow are resolved before they even create any jobs or pods, you can also do that. So in this specific case, I'm looking up each image and taking the resolved image value out of it. And then I'm creating a mutation webhook that patches all the containers with that resolved image. So it's like, again, 4 or 5 lines of YAML to get you to replace like custom webhooks that you might have created for CRD, such as workflows or tasks. So just to show you a demo, I'm gonna create a deployment without this policy applied. So in this case, there's nothing there that's actually mutating the image and changing it to a pinned digest. Now I'm gonna go ahead and apply that policy. Wait for a second so that the policy has time to register itself. And then I'm gonna redo that same deployment. And this time, hopefully the image should be modified and pinned to the exact digest. So this is right now going to the registry, fetching the exact digest and pinning the image to that specific digest. So this is, again, a very powerful capability. And you want to do this to avoid supply chain security attacks where someone is just pushing a new tag and replacing your valid secure image with something that's potentially going to cause failures in your cluster. So that's another impressive capability that Kyverno has, not just in terms of validation, but also mutation of resources. Next up, I'm going to show some of the new capabilities we've been adding, including support for the Sigstores cosign project. And this specific policy lets you do keyless verification if your images have been signed using cosign's new keyless mode. So what we're doing here is for all the pods admitted to the cluster, if the image matches this specific expression, we ensure that the subject of the certificate I was signed with starts with this specific string, and the issuer was GitHub Actions. So if you've used cosign in keyless mode with GitHub Actions, you'll know that this is like a fairly typical issuer and subject type for these certificates. So all we're doing is making sure that every image that's from Jim's repository is also signed in that same workflow. This specific root certificate here is the default full SEO root. You can also omit this, but we've just added it here to demonstrate that you can also switch it with your own. Like if you're running your own enterprise version of full SEO with a different root certificate, you can also switch that in. So it doesn't limit you to the keyless workflow that's available in public. You can also run it in air-gapped or enterprise environments. So I'm just going to apply this policy. And then I'm going to show what happens if I try to create a deployment with an unsigned image. So I have an image here that's unsigned, and I'm going to run it through our webhook. And you can see that it was blocked. We can try and make sure that like this is actually not signed. So if I run this through the cosign CLI, and if I check or if I try to verify this image, we'll see that this is indeed not signed. So now let's try and do the same thing with the signed image. So I know this specific image is signed. If I try to push that through the API server, we'll see that it goes through. But apart from simply admitting it, the image verify webhook also pins the digest to make sure that you're not tampering with the image and it's only admitting the signed image. And there are no inconsistencies if your image pull policy is set to a different value. So just to make sure that this is actually signed, I'm again running cosign verify. And you'll see that it's running this in keyless mode and it's actually verified that this image was signed. And like all of these claims were recorded in the record transparency log, and the certificates were derived from the full SEO routes. So I have one last demo before I reach the conclusion of this presentation, which is like checking the attestations. So apart from simple image signing, what you can do with cosign is also attach additional facts or metadata about your image. In this specific case, we've attached things like SBOMs. So we've attached things like SBOMs of Cyclone DX type. We've attached a vulnerability scan done by Trivi, and we've also attached some provenance data to the image. And this specific policy just ensures that all the images you're admitting to the cluster have all of these three things attached to them as attestations. So we want to make sure that there's an SBOM, there's a vulnerability scan that's recent enough and doesn't have any like super high scoring vulnerabilities, and that we have some provenance about the build system it came from. So let me apply this policy. And then if I do, if I run test again with the image that was signed properly and satisfies all these conditions, we'll see that it's let through. On the other hand, so like just to demonstrate that this is actually working, if I use cosign to fetch all of the attestations and everything, we'll see that there's a Cyclone DX SBOM, there's a Trivi scan attached to it that's recent enough, and there's also that provenance from the GitHub action that this was created from. So similarly, if I now try to run the same thing with an image that has all of these attestations, but the Trivi scan was a bit old, we'll see that the image is actually not let through. And it says that it failed the attestation scan for Trivi. So again, just to show that this was actually the case. Sorry, I think I'm checking the wrong image, but for this last image, the Trivi scan was a bit old, which is why it was not let through. Let me just see if I can show that.
Sam, we're running a little bit over time, so
Okay.
if it's okay, Sam and Jim, would you like to wrap up?
Yeah, sure. Let me just wrap up.
Go for it.
So yeah, we've talked through a bunch of demos and explained the various features that Kyverno has to offer. Last but not the least, I want to talk about a few other operational modes Kyverno can run as apart from an admission controller. So something that Jim mentioned early on is that you can also run Kyverno in audit mode. So even without enforcing all of these policies, if you just want to get an idea of what the state of your current Kubernetes cluster is, you can run all of these policies in background mode and use our policy report resource to figure out which of the resources in your cluster are in violation of the policies that you've defined. And we also have some nice UIs and integrations with Prometheus, Loki, Discord, or Slack to send you notifications about these violations. We also expose a Prometheus endpoint and also a sample Grafana dashboard so that you can monitor the state of Kyverno as a webhook. And also, as Jim mentioned, you can also run Kyverno in a standalone mode as a CLI outside of your cluster. So you can use this in your CI/CD pipelines to test your policies even before you deploy them or like when you're developing them. And you can also run these policies using the CLI against your cluster to again get an idea of what the state of your cluster is. So in summary, Kyverno is a Kubernetes native policy engine that can help you secure and automate a bunch of your Kubernetes workloads. It has various operational modes, so it's not just an admission controller, but it can work in CLI mode and also in a background mode. It is very much production ready, and it comes with the Neche mode, and it has a heightened security mode as well. It's fairly easy to get started with Kyverno, and it reuses concepts that you might be already familiar with. And that's pretty much it. Thank you for attending our talk. And if you're interested in joining the Kyverno community or learning about what we're doing, here are some nice links. And that's pretty much it.
Fantastic. Thank you so much, Jim and Sam. Really, really appreciate you presenting on Kyverno today. I know that you've already answered a few questions here, but just so that people can see them. Somebody asked, does Kyverno provide a dashboard, which you actually answered at the end, Sam, but yeah, it says you provide a graphical dashboard plus notifications, and can create cluster-wide policy and make exceptions, which is also answered by saying, yes, you can exclude by whatever attributes you want to. We're running a little bit over time, so I'm afraid that I can't stop and show for more questions or comments, but you already showed how to get in touch with the Kyverno community in case anybody has any follow-up questions. So fantastic. Thank you so much.
Thanks for having us.
Yeah, thank you so much for hosting us.
Absolutely. We're going to go now to a slightly shorter break than usual. We're going to do a 5-minute break instead of 10, and then we're going to come back for our third talk of the evening. So make sure that you settle in, and we're just going to take a short little break. See you in a few minutes.
Yep.
All right, everybody. I hope that you've managed to get yourself a drink, take a little bit of a break, walk around a bit. And we are going to go into our third talk now, which is Kubernetes security and governance made easy using Otomi. So I'm going to stop sharing my screen now. And Abhimanyu, you ready to present your, share your screen?
Can you see it? Yeah.
Yeah, looks good.
Oh, good. Yes. Hi, everyone. Hope you had a nice break. Thank you, Cheryl, for having us in Cloud Native London. And I'm Abhi. I'm the developer advocate at Kubes, a Kubernetes early stage startup from the Netherlands. And in today's talk, we'll be talking about Kubernetes security and governance made easy using Otomi, our open source project. So let's get started. A bit about myself, I'm the developer advocate at Kubes, and I've worked in a couple of other industries like flight simulation, autonomous robots, but finally ended up in the pure cloud native space. I do have other interests like endurance running, cycling, and yes, let's connect on Twitter. I'm quite active there, and also on LinkedIn. Let's go. A short agenda for today is a general introduction, and then we're going hands-on live demo, probably an extension of what the Kyverno team did. And then we'll talk about the open source community and contribution, how people can contribute to our project. Otomi, this is our 100% open source cloud agnostic platform that you can easily install using Helm chart. It's an application configuration and automation platform, which comes with integrated logging, monitoring, secret management using Vault, artifact management in Harbor, and then through an intuitive web interface, you can access all these applications and for every tenant, and also enforce security and network policies without having the need to write any YAML files or anything, just from the console. So, so what would you get at the end of the talk is the key takeaways are security concepts are quite complex in Kubernetes. So we want to abstract away all the complexities into a high level concept so that teams can easily adapt it and enable it, thereby bringing in a security driven mindset within the organization. So that's sort of where we're heading at. Otomi can do much other things, which I'll show you, but in today's talk, we'll primarily focus on the security side of things. So what we'll be doing now is I have a cluster running and Otomi is installed in it. And we're gonna deploy a rogue pod, similar to what Jim did. And then we'll be applying, so we'll be able to create the pod. It has host path volume mounted, so it has access to the host file system. Then we're going to apply the security policies via Otomi console. And then we'll see that we'll try to deploy the pod again and see what happens. So let's jump to the demo. And yes, so I have my terminal. I hope you all can see it. And now I'm going to deploy the rogue pod. You see that I can create the pod. There's a pod. I have access, and I did mount it to the hacked folder. So there you go. I'm able to access the host file system. And that's pretty dangerous, as you all know. Such a simple misconfiguration can screw up your entire cluster. So let's exit and delete this pod. And let's head to the Otomi console. This is the Otomi console. We have integrated several open source projects into one single console. And then if you see a red screen, it is the admin console where the platform admin or the DevOps engineer has access to it and can enforce network policies and security policies. And if you see a blue screen, that's going to be the team member who has limited access to certain apps. We have like control over it. And yeah, so now you can see that there's a policy window. We have all the policies in place, so we can go to the host file system, which is what we want to enable. So you have to note that we're not going to write any YAML file or anything here. We're just going to say host file system, enable this policy, and click submit and deploy changes. So what is happening under the hood, that Otomi is using OPA gatekeeper policy engine to enforce the constraints, and this will automatically get updated in the Kubernetes cluster. We use a GitOps way of doing things. So if you go to the apps, so any changes that you do in the console gets generated as configuration as code, get pushed to a Git repository automatically by the console. So if you can see, so this code was automatically generated by the console, and a pipeline is triggered. A drone pipeline is triggered. And if I go into the drone pipeline, so the pipeline is running now. And in the tests, we do a lot of validation checks against the schema. We check the policies and make sure everything is as per spec. So if it fails here, then it won't, the policies will not get applied. But if it's successful, then you will be able to see that we will not be able to create the pod. So by this, so for demo purpose alone, I'm just showing you one example, but you can have banned image tags. You can add more image tags if you don't want to deploy master, for example. Allowed users, you don't want root user access, container capabilities, you can add set capabilities. So this gives you the admin an intuitive way to just enable things and not worry about maintaining YAML files. And all those configurations are stored anyway in the Git repository for you. And we do leverage OPA Gatekeeper under the hood. So all these forms that you fill in here gets filled in the constraint templates, and the CRDs are generated under the hood. So it's deploying. Let's see what's happening. The logs automatically. Otomi is a multi-tenant. So as an admin, you can also create multiple teams. A team is a tenant in Otomi. In this case, I created a team called Cloud Native London. It not only has namespace, creates a namespace, but also integrates all the application needed for that particular team. And also the admin from this single console can enforce different policies and also network policies, which we will see later, through a single console from here. Taking time. Yes, so now the policies have been applied. So now let's go back and try to create this pod again. There you go. You see that the host pod volume, the admission hook is denied the creation of this pod. So thereby confirming that the pod, the policies were enforced. So that's the demo for the container security policies. Now let's head to the network policies. So for to demonstrate network policies, we'll be using a 3-tier microservice application. It's a front-end application, and there is like a Redis leader and a Redis follower services running. I've deployed these services now on the cluster. And then what we're going to do is we're going to access this application, and then we're going to enable the internal ingress filtering just from the console, which will deny all the traffic between the services. And then we're going to whitelist these services just via the console without having the need to write any network policies. Otomi will automatically configure these network policies, which we will see, and then we should be able to see the application back running. So, let's see. Yes. So let's go here. So we're back in apps and services. So there is this front-end application that's here. Welcome to CNL. Submit. So we do see that now the front end is talking to the Redis leader, and the follower and the applications are now working. So what we're going to do now is we are going to enable the internal ingress filtering straight from the within the console. We go ahead and we enable the internal ingress filtering. Submit, deploy changes. So what is happening under the hood is that Otomi uses network policies for ingress control and Istio service mesh for the egress control, and these get automatically configured when you enable or disable things straight from the console. So let's go to Gitty. There's a new commit now by the console. We made the ingress private flag to true. Note that we did not write anything. It's happening in the background. And now the pipeline is running. So these network policies and Istio service mesh concepts may be difficult to understand for a user that just wants to, deploy an app and whitelist trusted endpoints. So we decided to let users operate on a high level concept like Kubernetes services, public domain names, and IP addresses, and let Otomi do all the translation into the manifest and represent them as Kubernetes resources for you. So let's also watch what's happening in the terminal. So we're watching all the network policies that are going to get generated, and see when the pipeline succeeds, we should see that the ingress policies will be created. Okay, the test is completed. Now it's applying the changes. And this is also good for the admins and the team admins or the platform admins to see what are the resources that are getting generated, what are the different CRDs getting generated, and what is happening. And you have a track of all the changes that you made in form of logs and in form of commits. So it's all there for you in a truly GitOps fashion. Yeah, you see here, Otomi automatically has generated the network policies. And hopefully we'll also finish soon so we can also see it. Yes, so you see here, 2 new policies were automatically created, as you saw over here. So it's done. So now let's head back to the guestbook application. Yes, So the front end is not able to communicate with the Redis leader or the follower anymore because we have now denied all the traffic within the services. But we shouldn't stop here, right? We should go ahead and whitelist these services. We could just do that in Otomi by going here in the console, and we go to services, and let's create the remaining 2 services. So by creating a service, you're actually registering the service in Otomi so that you can build the entire infrastructure around it. So the name of the service should match as what we deployed in the manifest. So it's Redis leader 6379. It's an existing service, and we can also, by a click of a button, configure the exposure, ingress exposure, in this case is cluster, and we will now start whitelisting the application. We're going to say allow selected services, and we're going to choose the team name, which was the CNL, and the service was front end. We want the front end to start talking to the leader, and we also want the follower to start communicating. So we'll submit this, and we'll also create and register the follower service. Follower 6379. It's an existing Kubernetes service. Allow selected. And then within the team name, we'll have CNL. Service name, this is the follower. So we'll say the front end needs to talk to the follower. CNL namespace, the Redis leader also needs to talk to the follower. So we make sure everything is correct. 99 cluster, allow selected, CNL front-end service, CNL Redis leader. Perfect. So we submit it. We'll also verify the leader once. Leader, follower, yes. And we're going to deploy the changes. Schedule for deployment. While this is happening in the background, just let's head back to this. So we just saw scenario 2. Scenario 2. And now we have whitelisted the application via the console. Once the pipeline is run and it gets finished, we should be able to see the application, the front end talk again back with the Redis leader and the follower, and should be up. Similarly, I mentioned about the blue screen of a user. So in this is the admin console. We also have a user console. In this case, the user has access only to certain applications. The user also gets a space, for example, in Harbor, automatically configured when. So we log in as the CNL user, sign in. For the namespace, we have a Harbor space automatically created. So here, the team CNL can push their repositories, the image registry here, and we can perform the image scanning and use these images to from the console to deploy your applications. So all these comes pre-configured for the team. So the moment the team is created, all these are automatically configured, and the access control is also provided. So if I want, for example, let me head back to the apps, and I want to add a new user. We have Keycloak as IDP that comes pre-configured. You can also bring your own IDP, but let me use Keycloak or the admin user. So here I can create another user. Add user. There's a new, let's say a new team member is joined, and then I add CNL2, and then CNL2 at x1.com, CNL. And here I can automatically choose which group I want to add. Is it the admin group or the team admin group? And I say, no, I want to add it to the team CNL group. Save, I give some credentials. password is created. Let me log out here. And now I can log in as CNL2. Yes, so I have a new user automatically created, has access to that particular team namespace, and can see all the services that are deployed from here. And the logging for all the applications will be provided pre-configured Grafana dashboards. Let's see, mods. There you go. For all the services, you can automatically see all this straight away. But now let's go back and see if our pipeline is done for the changes that we did. Yes, it's done. So what did we do? Just a recap. We went ahead and whitelisted each of the services so that now we should be able to access the application. So let's go back to the guestbook application. Yes, you see, this was the first message we typed, and now we're able to get it. We say we are back. Indeed. So that was the demo on network policies, and you see how simple it is to configure network policies for your teams and whitelist applications without having to write any manifests or configure. You can just fill in a form in Otomi and it does everything in the background for you. Yes. Redcubes/Otomi core, you can find this on GitHub. We are an organically growing open source company. We're fewer than 8 people, so we are looking for a lot of contributors. Feel free to check out our project, and you can install it in your favorite public cloud provider of choice. Yesterday, we got it working in DigitalOcean and Linode as well. On top of, you can run it on AWS, Azure, Google, of course. And we are also, for documentations, you can check out otomi.io. And to join our community, we have a Slack channel and a Discord channel. Please join redcubes.com/community. And that's pretty much the talk. And if you have some questions, and feel free to reach out to us.
Fantastic. Thank you so much, Abby. That was actually really interesting. I don't think we have any questions from our audience just yet, but let's wait a few minutes and see if anyone has any questions. So once again, if you have questions for Abby about Otomi, then please go to this link, polev.com/showhung278 on your mobile phone or your laptop or your tablet, and you can post some questions. Actually, Abby, I wanted to ask you, what future things are you planning for Otomi? What things would you love to see from contributors?
We want to, from contributors?
Well, for yourself, and then also.
Yeah, so mainly from the contributors, we want more people to try out our product and see different use cases and how they play with it. We believe it's like this Swiss Army knife for DevOps engineers. They can deploy it on their cluster and they get complete access towards, creating tenants, and also that comes with all these integrated applications. We want people to try it out and come up with use cases and say, hey, can you do this? And for example, now after this talk, we're curious to see how we can integrate Kyverno into our as a policy engine. At the moment, we're using OPA Gatekeeper. So I'll probably reach out to Jim or his team to see how we can integrate the Kyverno into Otomi and do the same through the console, for example. What we're working on now is more on a modular and way to do things. So right now, certain apps are not optional, but we are making everything optional so that to lower the footprint of Otomi. And then you can just, we got it running on Minikube because it's an entire platform in itself, running Istio and all, so it's quite heavy. But now we have a modular platform where you can just drag and drop applications. It automatically reconfigures. If you want Grafana, you just drag and drop. It gets configured for your team and for your platform automatically. So that's where we're heading at. to a more modular approach. And we also want to integrate Flux in the future. So that's where we're at.
Well, I mean, Jim, since you're here, any thoughts on integrating Kyverno?
Yeah, absolutely. Would love to explore that. I think certainly, it can provide like some of the other use cases we talked about, like with automation, and also allow folks to plug in their own policies. So
Yeah,
let's talk.
for sure.
Cheryl, you're quite the matchmaker here.
Just coincidence, but I love it when these moments happen.
Yeah.
I'll connect you two afterwards. You
Sounds
can
good. Thank you.
explore how it goes, explore some collaboration.
Yeah.
All right. Thank you so much, Abby. I think we might not get any questions, but you already have the contacts. You gave the contacts, so if people have follow-up questions, then they can get in touch with you. Thank you so much. We're going to wrap up the meetup now. So,
right.
This is the end of Cloud Native London, April 2022. But if you want to speak or sponsor, then go to cloudnativelun.com. I think our next speaking slots are actually a little bit later than July now, but you can request a speaking slot, you can sponsor a future event, or you can promote your own events. I want to say thank you so much to all of our speakers, Suraj, Jim, Sam, and Abby, for coming to speak to us and sharing your insights and experience with Cloud Native London. And once again, thank you to our sponsors, Sysdig, Palo Alto Networks, and Circle CI. I'm your host, Cheryl Hung. It's been a pleasure to be with you this evening. Thank you so much, and I will see you in May. Take care. Have a good night.
Good night. Ciao.
Good night.